Again. Good morning, everyone. My name is Kieran Slaughter. I work for Renesas Electronics, and I'm here to give you a kind of light-hearted, informal presentation on developing IoT products. We're all here at an IoT show, and ultimately, most of us want to successfully develop, manufacture, and sell some kind of IoT solution. So I'm really calling on my experience over the years with Renesas and other semiconductor companies to give you a bit of insight into some of the pitfalls that I've seen and the companies that have successfully got over them. Renesas Electronics is a semiconductor manufacturer, so we make silicon chips, microcontrollers. We're number one globally for microcontrollers. But we've also, in the last few years, acquired a number of other companies making wide selection of analog power, sensors, and connectivity products. Most recently, Dialog Semiconductor, which is headquartered in the UK. So we're really involved in embedded design. I myself, I've been at Renesas for 15 years. I work in the IoT and infrastructure business unit, which is basically everything outside automotive. So that's the background I'm coming from. And as I say, most of my time in the semiconductor industry has been supporting microcontrollers and customers developing embedded systems. And most recently, that's involved a lot of projects with cloud connectivity. So as I say, I'll hopefully give you some insight into their experiences. I'm based in London, just 20 minutes up the road, and I work out of our office in Bourne End, which is near Maidenhead. So I'm going to categorise the pitfalls and topics into these sort of 5 broad topics. First, the viability. Yeah, if you're going to make an IoT product, it has to be viable. And you know, I've seen some pretty crazy ideas out there over my years, which you know, you got to make sure you got a good sort of design, a hardware design idea, and a viable business plan. Flexibility is important, especially at the beginning of a project. You've got to build in some room to have a flexible product that's maybe going to be able to be adopted to changing business situations. Security is a very important topic for IoT. Not going to go into that in detail, but just give you a sort of a few pointers. Scalability, that's about getting the product to market and ramping it into volume production, which as a semiconductor company, I'm obviously interested to make sure that you do, because otherwise you're not going to buy many products from us. And sustainability, not just in terms of you know, the environmental impact, in fact, more to do with having a product that's sustainable over the long term. So not just launching a product successfully, but actually keeping a business going for many years on the back of it. So first thing is the anatomy of an IoT system. As I say, lots of companies here that are dealing with it, the sort of IoT market. And a lot of them are focused on, you know, things like the web dashboard and, you know, developing a smartphone app. And you can spend a lot of money on this, and this is obviously quite often it's the customer-facing part of an IoT solution. So you might want to spend a lot of money making it nice and pretty. And then you've got the cloud side. So you've got your cloud server and maybe some applications doing your data aggregation and data analysis, all presenting it onto the user through the web interfaces. But what I'm obviously mostly involved in is the embedded device, which is actually the thing itself, the thing of the Internet of Things, and its connection to the cloud, but also to the real world. So I'm not going to talk about these things on the right at all. Those can be, you know, there are other people that are much more expert and able to tell you about those things. I'm going to be talking about the embedded device. So just as a show of hands, how many people here are involved with embedded electronics design? A show of hands, maybe half or something. Good, excellent. For the rest of you, I've included in the presentation some obscure song titles that you might like to identify during the presentation. And there's a special prize for the people that do most. So just going into an IoT design and taking sort of two extremes of what you might come across. We've got a lot of customers using our semiconductors that already have quite complex embedded systems designs. They might have, be making something like a white sort of home appliance or something like that, and all their expertise is in motor control and user interface and things like that. And maybe they want to add cloud connectivity to it. So the majority of their expertise and design and effort is going to go into their core product, and that's where most of their customer value is. The cloud connection is kind of an extra sort of icing on the cake, might even be a bit sort of gimmicky. So the question is, do they actually spend a lot of resources internally developing that cloud connectivity solution, or maybe they'd be better buying it in, either in the form of a solution, a module, and there's companies, UK-based company, one springs to mind called Electric Imp, who made a really good sort of add-on cloud connectivity solution. Or they might be better contracting a consultant with some expertise in this area to develop it for them. But certainly, it's going to be a minority of the sort of design effort. So you might set a washing machine, or maybe somebody doing 3D printers that want a cloud connection. It's not the main part of it. And then on the other side of the scale, you've got quite a simple sensing and control application where the cloud connectivity is really the unique selling point of it. So that's the thing that gives its value. So maybe an internet connected light bulb, for example. You can buy a light bulb down a hardware store for £1. If you want an IoT connected one, it's going to cost you like £10. So the majority of the value is in the cloud connection, being able to turn it on and off on your smartphone or whatever. And the sensing and control bit, that's a small part of the effort involved in designing it. So yeah, obviously this is a much better real sort of IoT design. Most of the designs in the cloud connection. So you might be talking about a remote switch or maybe a thermostat. In the middle, you have some applications where there's quite complex embedded design, but where the cloud connection is really a crucial part of it. So you might take smart meters, a classic IoT, real high volume, first real IoT design, I would say, in the industrial market, where it's a traditional product with quite a lot of design gone into the main product, but the cloud connection really makes it a kind of a new product and really adds to it. And then security systems, where you've got traditional players in the market that have really been taken by surprise by new people coming to the market with cloud-connected domestic sort of intruder alarms that can give you remote notification on your smartphone. And as I say, that's kind of in the middle, because these kind of products can really shake up a market. So yeah, thinking about a viable design, whereabouts are you on this sort of scale? Next sort of consideration of viability, and one of the key decisions you're going to make as far as hardware, is what you're going to have as the central sort of processing unit of your hardware. And that can be a microcontroller or a microprocessor. So if your application requires very low power, maybe it's battery operated, perhaps physically small, then microcontroller could be, obviously the way to go. But you're limited to quite a simple user interface. You're not going to have graphics and video running on an IoT. And also the thing that you might have is this lightweight artificial intelligence. Edge AI done on a micro has got to be fairly limited in scope. And there's a few examples I can think of. So for example, a learning thermostat. So a thermostat which has maybe a presence sensor, PIR detector, that can tell when you're in the house. It can record when you adjust it so that it learns over time what your preferred temperature is. That's a kind of a lightweight AI task that a microcontroller can do. There's a few other examples that maybe other people today are going to be talking about. If you've got much higher requirements as far as processing, maybe you've got a complex user interface, a graphics display, maybe you need to do video processing, then you're going to have to use a microprocessor, typically, running Linux. If you're going to do that, you almost certainly need to be mains powered, because you're not going to run long for a battery with that. But obviously the hardware is going to be much higher cost, and typically most applications are going to be lower volume. Although if you work for Amazon or Google, obviously they've got examples of high volume processor-based IoT devices. Anybody work for Google or Amazon here? Anybody? Similar companies? No, never mind. Yeah, but you also got to consider your technical expertise. These two areas, as far as hardware design and firmware design, are quite separate in the embedded market. So requiring different levels of, or different types of technical expertise. The costs and resources required to develop these is quite different as well. And typically a microprocessor-based system is going to take you a long time to get to market, if you've got limited resources especially. So here's an example. I know you can't get away. I work for Renesas. I'm obviously going to put a few Renesas specific slides in here. This is an example of a microcontroller you might use for an IoT project. It's based on an ARM Cortex M33. But some of the features that are specifically, you will look for in an IoT micro, lots of memory, lots of RAM as well for your networking stacks. You need typically quite a lot of RAM for all the data frames you're going to be processing. Some connectivity like Ethernet, if you've got wired networking, that's obviously good to have on board. And hardware security. So many of Renesas micros have got hardware security for authentication encryption, and I'll go into that a bit later. Another example of a microcontroller. This is a micro that comes from the recently acquired Dialog semiconductor. And the main networking interface is Bluetooth Low Energy. So this is actually a micro that's developed for wearables and things like smartwatches. So BLE is used as the main interface. It connects to a mobile phone, and that's a gateway to the cloud. I still argue that is an IoT design, even though you require a gateway. So some other features it's got on it: security again. You've got very low power voice activity detection, which you're starting to see on wearables. So you can have like a keyword to wake up, or you can say, "Watch, show me my heart rate," or something like that. It's got a separate processor for doing sensor processing, so your accelerometer or gyroscope, again with very low power, so you get decent battery life. It's got integrated charger and power management, so it's basically like a single chip micro that's doing all the stuff that's associated with a wearable. And again, as I say, it's a microcontroller, low power enough to get a decent battery life. So here's an example of a microprocessor. So this is a dual-core ARM Cortex A55 running at 1.2 gigahertz. So you're talking hundreds of milliamps, if not amps of current. It's got so it's pretty high performance. It's got separate video and graphics processing capability, 3D graphics and a video codec. So you can do hardware video compression, decompression to send over the network for things like image processing or recording. It's got some real-time features on it as well, though, so that you can connect sensors. It's actually got a separate ARM Cortex M33 CPU to run, real-time, and also for things like fast boot up. So a lot of IoT devices, even if they're running a processor, you want them to be able to start up very quickly to maybe capture an image or react to some event. And that's also able to do the power control as well. Even if it's mains connected, you want it to be reasonably reasonably power efficient. And again, hardware security. You can see a theme coming through here. All the stuff, all the micros we promote for IoT designs have got hardware security on them. And here's an example of the kind of thing that you might have in a processor. So I think this is a Google Nest with video. I can't remember the exact name of it. I'm not saying that there's an RZ processor in there, but it's the kind of thing that you would need for that kind of application. So next thing we want to consider is connectivity. I've already mentioned Ethernet, but Wi-Fi is another popular way of connecting an IoT device to the cloud. Cellular as well. You do have some low power RF, some of these kind of emerging standards like Matter, Wi-Sun, which is a technology we are quite deeply involved in, which is used for smart city applications and metering. And there's also things like BLE, LoRa, which you need a gateway, a proprietary RF gateway to connect to the cloud. So, arguably some of these aren't really IoT networking standards. Sometimes actually IoT devices will need multiple network interfaces, and this has implications for security, for where you put the networking stack. For example, maybe an intruder alarm, you would normally connect to the house Wi-Fi for your network connection, but that's vulnerable to getting somebody cutting your telephone wires, for example, or interruption in the network provider. So you might have a cellular interface as a backup, but it's expensive to use all the time. So you might have dual networking. And as I say, your design's got to cater for that. So again, bit of a pitch for Renesas technology suitable for these connectivity technologies. This is again another Dialog product, very exciting, interesting product to come from Dialog. It's a very low power Wi-Fi system on chip, so suitable for battery applications. You can actually get months and months, if not years, of battery life in something like a smart radiator thermostat. So these are particularly useful in these times of rising energy bills. But this can connect directly to your Wi-Fi access point, and you can control the temperature and when the radiator comes on and off. Another application is hotel room keys. So I was in San Francisco last week, a global applications conference. And the room, the hotel I was staying in, it was a small hotel, not as part of my business, had a smart. You actually accessed the room via your smartphone, so it had Wi-Fi and BLE in the room lock itself, but it was battery powered, so that you could download the key to your phone and then open the door with it, and all the communication was done over Wi-Fi. So that's the kind of thing that you need low power Wi-Fi for, and we do a chip-based solution or a module-based solution, and the module's like certified worldwide, all different standards. So even in a low volume sort of prototyping, you could use something like this for an IoT design without having to worry about all the certification. And Renesas also do cellular modems now. We partnered with a company called Sequans, who are a French company, do cellular chipsets. Quite a limited range at the moment. We really just have one device that's in the market, which does LTE Cat M1. We will have more products in the future, but if you need something with more flexibility than that, then our distributor Anglia, who were here today with on the stand in the exhibition area, they have a franchise Thales, who do a really wide range of cellular modems. So I would recommend looking at them. The thing about LTE Cat M1 though is that it really opens up a whole new world of possibilities as far as low power cellular connected applications, because you don't need like really high peak current when you connect like you do with 2G. Then you can have battery operated devices with a cellular connection and long battery life. So really, as I say, similar to our Wi-Fi, we're opening up new applications to having that IoT connection. And here's some examples of things that use cellular modems for IoT. So I mentioned smart meters earlier on. In the UK, all the smart meters are connected via cellular. If you didn't know, in other countries it's maybe power line communications. And this is a sort of car black box. So if you're a young driver recently passed his test with a hot hatchback, you'll probably have one of these under your dashboard, and it connects to the insurance company by cellular. So going on to flexibility. So I'm just going to briefly talk about flexibility. As I say, this is typically when I talk to a customer starting out in a project, their specifications quite loosely defined. They have a whole load of ideas about what it might be able to do, what might be the revenue streams they're exploring to actually make it a viable product. What I would say is that it's good to have that flexibility, but only to a certain extent. You've got to get the balance right. So what you try and do is get the flexibility in the cloud or on the app, because those are things that are, from a logistics point of view at least, easier to update than the hardware. When you got the hardware out there, you don't want to have to touch it or visit it or update it from a physical point of view at least. You might have some modular hardware design, maybe some PCB assembly options. So you might have some sensors that you think maybe I'll mount them or maybe I won't. But generally the hardware needs to be constrained to guard against this feature creep and what I've called here a cliff edge. So I had a customer that was designing street lights, and so fairly simple control and sensing. But then, so they wanted to make it fully IoT connected. And then they had the idea, maybe we could have a video streaming and object recognition in the streetlight module. And I was like, oh, that's a completely different kettle of fish from a hardware point of view. At that end, unless you can decide on one or the other, your hardware's up in the air for indefinitely. So just beware that sort of cliff edge. It also connects, as far as the connection, flexibility, you need to think about what your kind of use case is. So having an always-on connection. If you want to be able to control the device in real time, like you might need to do for, say, a hotel lock, or I'm trying to think, maybe a security alarm, then you need an always-on connection where it's permanently connected. The other option is only to have the device connecting periodically, maybe prompted by some external event, or every half an hour or so. And in that case, you might have a shadow device on the cloud, which is basically got the latest information that it got, and you interrogate that rather than the device itself. But then it means you can only update the device and what it's controlling, once when it's connected. Basically, the key point is that you have to freeze the hardware design at some point if you want to roll out a product successfully, and that is hard. But the number of times I've seen people that are prevaricating on the hardware and they never get to market, it's really important to do that, and that's down to the marketing people to decide what it's going to do. So going on to security. As I say, I'm not going to go into security in detail. There are other sessions, I don't know if today or not, but many other things on the internet that can talk in detail about security. I just wanted to lay out three main sort of guidelines that are kind of good idea from a high level. Firstly, draw up a security policy. So this is a thing that can be done from a non-technical point of view, a sort of board level, a company, where you identify sort of vulnerabilities. What are the data that you want to keep to yourself? What are the implications of that data being hacked or stolen? And do you need to protect against that? What's the damage going to be if that data gets out? You cannot protect against every eventuality. That is the key thing about security. If somebody with £1 million, an electron microscope, with all sorts of semiconductor decapping technology, is going to have a go at your hardware, they're almost sure they're going to be able to get your secrets out one way or another. But if you're developing a smartwatch or something like that, a wearable device, what's the data they're going to steal? Is that worth £1 million to get it out of one watch? Probably not, right? On the other hand, if you're developing like a digital cryptocurrency wallet, yeah, you probably want to do as much as you can to protect it. I've never dealt with somebody developing a cryptocurrency wallet, I have to say. It's a hard challenge. But yeah, so drop a security policy, decide what you want to protect against. Secondly, don't leave it to the end of the design, right? Now, I'm not saying you need to do all the security up front, but decide how you're going to do it in the first, right up front. So decide how you're going to do it, how much it's going to cost, what resources you need, what expertise you need, what hardware you need, and then you can maybe leave it till later on in the design once you've got like everything, all the networking and all that up and running. But plan how you're going to do it first of all. And thirdly, don't try and do it all yourself. Unless you're a mathematics, crypto, cipher genius with a lot of his time on their hands, then it's stupid to try and attempt to develop your own encryption standards or security protocols. Use industry standard protocols and choose partners that have got or even open source software that's got a pedigree and proven track record. Going on to a bit about data communications. These kind of terminology, this is kind of buzz terminology, but this is absolutely standard now for IoT. So MQTT is typically the packaging technology used for IoT connections. And you can consider in a not technical way, this is like an airmail envelope. So it's not really, people don't send airmail anymore, but you used to get lightweight envelopes that were, thin paper that you could send, and it was the lowest cost way to send a letter abroad. And MQTT is a bit like that. So small amount of data, you can print it, you can have it in one page, and it's ideal for microcontrollers that don't have a lot of memory and small messages that you want to publish a small amount of data. So MQTT is this publish-subscribe model. So anything like a sensor would publish a topic like temperature, and subscriber would be the MQTT server. And it would subscribe to that topic and maybe publish some control switching topic, and the thing would subscribe to that data. And it means that every time they connect, they can get the latest version of that data, and everything happens quite efficiently. So MQTT is the envelope, and if you consider the TLS, the security, is like a wax seal. So again, it's hardly modern technology, but it's a good analogy. This is if you receive an envelope and it's got a wax seal on it, you know who it's from because of the imprint itself. Only that one person has got that little ring that can make that imprint in the wax, and nobody has read the letter because the seal is intact. So nobody could have read your the letter, and nobody could have tampered with it either, opened the envelope. So that's like TLS. This is a standard used for Internet Protocol security. So on your web browser, if you see that little padlock appear on your address bar, that means that the website is protected by TLS. And TLS uses this thing called public key infrastructure. So again, on your web browser, if you ever see a message that comes up and say this website security certificate has expired, proceed at your own peril. That is public key infrastructure where the website has a certificate for authentication. And IoT uses that same mechanism to both authenticate the server and the device itself. So it's a really tried and trusted method. And it uses these things called asymmetric and symmetric encryption, and that is what you need to implement in your firmware or in the hardware to make encryption and authentication quick and efficient. So this is a hardware encryption or crypto engine that's implemented in a lot of Renesas microcontrollers. So it's got the algorithms here like RSA and elliptic curve cryptography, both for the authentication and the AES is for actually encrypting the data as well, all in hardware, so it can be done pretty quickly. It also has some key wrapping technology, so you can encrypt the keys themselves and store them in memory. And if somebody steals that key out of the device, somehow manages to get hold of it, it can't be used on any other device because it's unique to this specific unit. And that's quite important. If you don't want to, even if somebody with £1 million probes your smart meter, for example, your energy meter, which they could do, and they manage to break that meter, you know, £1 million, okay, they can now get free energy for that house forever. But that's how much is that? You know, even at today's prices, it's probably hardly worth it. However, if they broke your whole security scheme because they all used shared keys, that's another problem. So yeah, unique keys are good. Yeah, and it's got things like random number generator for generating encryption keys, and the whole unit, the whole hardware unit is isolated from the rest of the micro. So even if somebody manages to hack into your firmware, they can't steal keys and use the crypto engine. I'm running out of time, so I'm going to skip over this slide. Scalability. So can you make it? Can you make it? One of the things that people talked about today is component availability. I'll just get a little plug in for Renesas. We have been making hay like Billio the last couple of years because we have our own fabs and we have had much better availability on our micros than many of our competitors. So we've won lots of new designs and we still got great availability. Go on our website, check out how much stock is in our distributor network for our ARM Cortex micros. It's great. So yeah, please, availability is a key concern. Licensing IP, not just hardware, things like encryption algorithms usually have licenses, even if they're open source associated with them. So you need to consider that. Can you get it working? So this is a topic that is worth a whole presentation in itself. And again, it's not something I'm going to talk about in detail. But provisioning and device identity. So Crypto Quantic are here. They're kind of experts in that area. But this is where each device has to have a unique identity so that it can then be registered on the cloud and be then provisioned. Provisioning means that with its certificates and registered on the server. And if you look at a consumer device like this is a Google Nest, I think, you'll see that underneath there's an ID, and you get the Google app on your smartphone and you put the ID in, and then your secure connection on your mobile phone allows the connection to be made between the device and the cloud, and then they can exchange data and the provisioning takes place. On an IoT thing, that kind of interface might not be possible. You could try and replicate it with a BLE interface and a smartphone app, but you have to think about it from the start because it's a hard problem. As another example, like BBC iPlayer, if you log into BBC iPlayer on your smart TV, it gives you a unique ID that you go into your BBC account and you put in, and then that does the provisioning of your TV with the iPlayer so that the BBC knows what programs you're watching and you've got a license and stuff. Can you make it reliable? So this is especially important for consumer device, high volume consumer device. I'd say any device, in fact. But you want to be able to detect bugs if they're in the field. And maybe you've got a device that you never want to touch again. You want to have it out in the field. But if there's bugs in it and it's crashing, you want to know about it and you want to be able to fix them with firmware updates. And this is particularly something that the wearable guys have got really good at, right? So I've got a Garmin smartwatch, and it will do a firmware update in the background. I hardly even notice. And when smartwatch guys, they roll out a new product, within hours they can aggregate users and see what's causing crashes and deliver a firmware update without you even ever encountering the crash yourself. And that technology, as I say, we more familiar with through our acquisition of Dialog. And they have a partner called Memfault, and who have done a webinar called Launching an IoT Device, a Blueprint for Success. You can go onto YouTube, watch this webinar. Really recommend it if you're facing that challenge. It's a good lesson, and even if you don't use Memfault, some of the techniques they are proposing are really good. For that, you need to obviously implement secure and robust firmware updates, and including updating certificates. What I talked about as far as security, you need to be able to do that in a secure way. And choose the right partners. Again, loads of people involved in IoT, different expertise areas. Nobody can do it all. You have to, get expertise from a number of different sources to get that expertise. So, sustainability. Now, I'm not talking just about sustainability. As I say, it's more about having a product that's going to see the distance, not just have a successful launch and sell a few thousand pieces, but actually give you a long-term successful business. So, one thing that a successful IoT device have got is an ongoing revenue stream to support maintenance and all the costs associated with maintaining a device. So, don't know if anybody is familiar with Amazon Dash. So this was a little Wi-Fi connected button that you put in your, your bathroom cupboard, and every time you were running short of razor blades or something, you pressed a button and Gillette would send some to you through Amazon. And so Amazon did a deal with Gillette, and they paid for some of the hardware costs, and then it all was supposed to be really cool, but it didn't work. Consumers just didn't like paying extra for the razors. They could pick them up when they're at the supermarket anyway. It's not really saving them much time. It was kind of like a solution in search of a problem. However, on the other side, you've got HP Instant Ink. So this is a subscription that I actually use. HP, my printer at home, I pay £2.99 a month. They monitor how many pages I'm printing. They can tell when my cartridge is running low of ink, and they'll send me a new one before I even know that I need it. And I never run out of ink, and I can always print paper. It's great. It's great when you've got kids as well, and they've got their school projects, and they print off loads of photos or something. So yeah, that's something that really works for me, and obviously a successful business for them as well. So yeah, is the customer value worth the original and the ongoing outlay as well? So life cycle management as well, something that as with smartphones. You'll see if you buy an Apple, it will say, we will support updates for 5 years, maybe Android phone is like 4 years or something like that. But you, as an IoT manufacturer, have to give a similar sort of commitment, not just legally, a year or two, maybe more, but morally for your customers, you have to have a plan to make sure that you support security updates and firmware maintenance for the long term. And at the end of the product's lifetime, you have to make sure that you have a process to securely decommission. You don't want the product ending up in a waste paper bin or a bin or a landfill or something. Somebody picks it up and gets your customers' security details off it. And ultimately you need to have a expectation that the whole unit is going to be replaced at some point, maybe by consumer purchase, but also maybe by a subscription cost that pays for that replacement, like maybe a security alarm, monitored security alarm. So last thing I'm going to say, and just got a minute or two left, is we're on the Anglia Renesas stand in the exhibition area. This is a cloud kit that we've done that uses one of our ARM Cortex-M microcontrollers with a LTE Cat M1 module. Comes with a SIM card, which unfortunately doesn't work in the UK, but talking to 1CE about it, hopefully they can sort us out. Yeah, it's got like connects to AWS and a dashboard. You can also connect via Ethernet, which does work. But it's a low-cost kit that gives you all the building blocks to build a successful low-power IoT device. Got a lot of expertise and solutions tied up in that. So that is it. I'm not sure we've got much time for Q&A. We don't have time for Q&A, but please, if you've got any questions, you want to discuss your project, come and talk to us on the Anglia Renesas stand after, and I'd be more than happy to answer your questions. Okay, thank you.